So class average was a 53, but that's kind of misleading because you had grades on the extremes. Um, I feel like the median it says was 60, so I guess that gets closer. Whatever. So we had three people who got 90 to 100. I think two of those were 100s. A couple people in the 80 to 89 range. Um, four people 60 to 69, and two 40 to 49, two 20 to 29, 10 to 19, and then a 0 to 9. We had two people 0 to 9. So now if we're kind of compartmentalizing this, so remember, first of all, that no matter what you got in this exam, you can completely fix it, right? The way I do things is if you do better on the final exam than you did on the midterm, I'll replace your midterm exam in its entirety with what you get in the final. So if you bomb the heck out of this one, then you can fix it completely. But at least this should kind of show you where you're sitting competency wise in the class right now. I would say if you're in this group up here, the 60 or better on this exam, certainly these folks, could have done a little bit better. Some of it might have been time crunch. Some of it might have just been things haven't just quite clicked, but I feel like you're probably close. So if you're in this group here, you're probably in decent shape. All right. Now, when you start getting down into this group, hopefully these folks are on their way up. But this should show you this group, these folks down here. How would you get less than 0? Can you actually get less than 0 on a? Yeah. I don't know. But it's I get it's like this person did so little. I can't give them a 0. It's not worth a 0. Yeah, I don't know.
They already had deductions applied to the exam beforehand.
I gotcha. Yeah, but in any case, if you're on this bottom tier thing here, evaluate why your grade was crappy. Was this lack of effort on the homework? Was this maybe doing the homework, getting the points, but maybe working with other people and relying too much on them, not learning enough of the stuff on your own? I want you to collaborate with other people, but part of that collaboration should be that you're learning from them. Because sometimes it's easier to learn from a classmate than it is to learn from the teacher. I might do things one way, or I might, do things relatively quickly because we need to get stuff squeezed into the class. So working with classmates can sometimes give you at least a different angle on stuff. But if you're one of those folks that did poorly and you're working with somebody else or a group of people on your homework assignments, you might be doing well on your homework, but didn't do well in the exam. That should at least tell you the story that you're not getting as much out of those homework sessions as you need to be. So ask more questions, try to be more involved in the process, things like that. I know if you fell behind, one thing I say with programming is it's kind of like a sport. So it's entirely possible that if you're in this group here, things just have not clicked yet. So I promise you, at some point, if it's in you, at some point you might go from completing competence to A and B, and it might happen almost over a week, where just something falls into line, and all of a sudden all these other things that were complete gibberish to you start making sense. So if you believe that you possess the skill set, and for whatever reason, just things haven't, whether it's effort or whatever, it just hasn't clicked yet, that does happen. But I would have tried to evaluate yourself and figure out why you're in this group. When you make a decision on whether or not you should, A, stay in the class, B, change your study habits, blah, blah, blah. Make sense? All right, so let's go through the exam and then we'll go from there. After class, if you have questions about points, if you think I took off too many points, come up and I'll tell you why I took off those points. If you think I gave you too many points, let me know. And I'll take some of them back and distribute them to other students. Nothing, no, just a dead class. All right, so write an error-free Hello World program. Let's see, let's open this up in where do I want to write this? Open it in text edit. All right, so number one, public. Well, it's going to do, is there a way to turn off, will it do auto correction if I make it plain text? It will. All right, then we're doing it in Eclipse. Okay, I'm just going to create another file in here for the exam. Call this guy midterm. All right, so for a error-free hello world program, public class something, public static void main, string array args, or whatever you want to name that variable, system.out.println hello world. All right, so precisely like that. So for it to be an entire program, you have to have the public class, then you have to have the public static void main. So this guy needs to look exactly like that, with the one exception that you can change the name of your variable to be something other than args. Usually the example I do in class, I call it elephant or something like that. Then system.out.println hello world. So this one was graded in binary. So it was either completely correct or completely wrong. I think I maybe gave a couple of some mercy in a few places where if somebody like just forgot the semicolon or something like that, I took off a point. But in general, this was either completely right or completely wrong. All right. Number two, what's the difference between public and private, and when would you use each? So public means that the member that's public, whether it's a variable or a method, is available anywhere in your entire application, okay, even outside of this class. Private means that the member, the field, or the method is only available within that class. All right, that's the distinction of making something private versus public. So when would we use each? Well, we use private when we are creating, for example, fields inside of a class like our superstring, and we wanted to protect the data we're holding so that it's only directly accessible within that class. And then when we need to expose it to other folks, so other classes, we would give getters and setters. So we give a function to allow you to get that information, or another function if we wanted you to be able to change that information, right? So it allows you to, we can control access to it by making it private and then loosening the reins a little bit through functions. Where public gives us the flexibility of having something accessible outside of things. So for example, again with our superstring, inside of our superstring we had the main field, which was the S, I think, was private. So we could only directly access that guy inside of our superstring. But we had a whole bunch of functions inside of superstring that we made public, because those are functions that we wanted to be able to access from within our driver class or something like that. We wanted to be able to create instances of superstrings and then call those public functions. Make sense? All right, so that's the public private thing. Explain why the char primitive type is actually stored as an unsigned 16-bit integer. So this has to do with the Unicode character set. This question was actually missed more than it should have been. So the char primitive type actually works as a mapping to the Unicode character set. So we have 65,536 unique characters in the Unicode character set. I didn't necessarily care if you came up with that exact number, but we have a whole bunch of characters in the Unicode character set, and our char primitive needs to map to those guys. Why? Because computers like holding numbers. Okay, so computers are good at storing numbers. Why is the char primitive type unsigned? because we only need to represent positive numbers, the numbers between 0 and 65,535. We don't need negative numbers. So if we're trying to efficiently store the corresponding Unicode value, how do we do that? Well, we need to give ourselves a big enough bucket to hold the number in, and it only needs to be able to hold positive numbers. So we would make it unsigned. Happens to be a 16-bit unsigned number because we're going to hold values in there between 0 and 65,535, and those guys will then get mapped to the equivalent character in Unicode. So that's why something in that ballpark is why the char primitive type is stored as an unsigned 16-bit integer. Questions about that one? All right, write the necessary code to define an integer array capable of holding 25 integers. So that would be something like int array AR is equal to a new int array 25. Like that, just this one line. That's an integer array capable of holding 25 integers. Write the necessary code to fill an integer array named AR with the value 5. All right, so we don't necessarily know how many characters in that integer array. So, I mean, some of you assumed it was the AR from the previous question, which is fine if you wanted to do that. But to fill it with the number 5, we would say for int I is equal to 0, I is less than AR.length. That's the number of buckets in AR. I plus plus. And then each time through, we would say AR at bucket I is equal to the number 5. So this fills an array called AR with the value 5. Make sense? You thought arrays didn't have a dot length. Now we specifically talked about how strings dot length is a function, arrays dot length is a field.
Oh, I see.
Remember that? Yeah. So this length here is a field. How do we know? Because it doesn't have the opening and closing parentheses on it. But if you did everything else right, if you assumed it was this guy up here and you said I was less than 25, I guess it's possible I would ding you for a point, but generally speaking, you showed me that you knew that I had to spin through every bucket of it, and I knew how to fill each bucket with a value. Make sense? So I guess I care a little about that piece there, but if there was a misunderstanding what I was asking and you still showed me you pretty much knew what that arrays are things you have to go through and you got to put stuff in each individual bucket, that's what I was mostly looking for. All right, so now 6. Define a class named car that stores the number of wheels, the number of maximum passengers, and the color. So here we'll actually define it as a new class. So I'll create a new class here. This guy will be called car. So here's our car class. You need public class car. And what are we storing? We're storing the number of wheels, the number of maximum passengers, and the color. So number of wheels is probably going to be an integer. Number of maximum passengers will probably be an integer. And the color may be a string for representing the color. And then write an appropriate constructor for that class. So I wanted you to show me you understand what the purpose of a constructor is and that kind of stuff. I didn't take off for this, but realistically, I've taught in class that you should make variables as private as possible and then loosen the range as you need to. So we probably want to make those fields private. So we would say private int, what is it, wheels, num wheels, private int num passengers, and then private string color. And then we would have a public constructor. Constructors must match the class name. So public car. And this guy would take in 3 variables. So maybe name them num wheels because that's what make the most sense. Num passengers and string color. And then we would say this dot num wheels is equal to num wheels. This dot num passengers is equal to num passengers, and this dot color is equal to color. Now, if you wanted to make a distinction between these variable names and these variable names so that you didn't have to say this dot, you could have. But you needed to show me that you understood that the purpose of the constructor was setting these fields equal to these values that are passed into the constructor for a car. So I'm setting this particular car's number of wheels to however many wheels were passed in. This particular car's number of passengers equal to the number of passengers that was passed in. And this particular car's color equal to whatever the color was passed in. Make sense? So that would have been something along the lines for that one. Questions about that? Write a simple program that illustrates two variables with the same name that are distinct because they are separate in separate scopes. All right, so we'll come back here into our midterm. This will work. Well, we could make it public if I wanted to, but let's just say void A int b equals 5. Well, let's do int num is equal to 5. Void b int num is equal to 9. So something along you didn't need the main thing here, but something along these lines where you had a class, and inside the class you had a couple of functions, and one of the functions had a variable called, in this case, num, that happened to be equal to 5. Another function had another variable named num that happened to be equal to 9. So this guy has his own scope that lives and dies with that function. This guy has his own scope that lives and dies with that function. So that would be an example of a variable with the same name that lives in different scopes. You could have done a similar thing with like for loops. You know, we could have come up here and I could have said int I is equal to 13. And this would have been a good example as well. Here's I in that scope. Here's I in a brand new scope. Same variable name. Because I died at the end of this for loop. Because its scope was attached to this for loop scope. Well, I mean, they would have different values, right? This guy would, in this case, this guy would go up to 25. And then afterwards, there isn't an I in that scope. And now here's a brand new variable I that has a brand new value. I mean, it could even be a different type. I mean, we could have said this guy was string I is equal to LOL or something. So we have two variables named the same thing. In this case, they're even different types. They hold different values. So that would be another way you can show it. So I mean, you could have shown this many different ways. What was I testing on is the understanding of scopes, right? Understand that there are different scopes, and you can have variables that share the same name as long as they are in different scopes, so they're not conflicting with each other. Make sense? So plenty of right answers there that you could have done. I mean, it was a contrived example to show me you understand different scopes. But probably the easiest thing to do would just create a class and throw a couple of dumb functions in it and put the same variable name in both functions and move on. Here's a scope. Here's a scope. Doesn't matter what the name of the variables are. They definitely don't conflict, right? Let's see. Write a simple. Oh, that's two variables. Okay, that was 7. So now we're on 8. Convert 1B9C from hex to binary. All right, so this one actually should have been pretty easy if you knew the trick, which I think we've shown in class before. So 1B9C, hexadecimal is base 16, right? So let's see how do I want to do. Well, I guess we'll solve it inside here. I'll just do a multi-line comment here. So it's 1B9C. So hexadecimal, we could actually represent in binary groupings of 4. So we can say what is, because we're converting it to binary, right? From hex to binary. So what is the 4-bit version? And quick question, why is it that I can represent hexadecimal, they're called hextets, hexadecimal digits, with 4 bits? Why do I need 4 bits? Why couldn't I do it in 3 bits? Hex is, what are the legal values of the hexadecimal? 0 to what? 0 to 15, or 0 to 9, then A through F. That's how we represent it, right? So, but we have 15 unique things there, 15 unique values, 16 unique values. All right. What's the largest value I can represent in 3 bits for binary? We have the 1's place, the 2's place, the 4's place. So the biggest value I can represent is a 7, right? What if I go to a 4-bit number? 1's place, 2's place, 4's place, 8's place. 8 plus 4 plus 2 plus 1 is 15. So 0 to 15. So 4 bits is the exact correct number of bits to represent all the potential values in base 16. So a 1 is 0, 0, 0, 1. Now a B, that's actually the number 11, right? So that's going to be an 8 plus a 0 plus a 2 plus a 1. A 9 is going to be an 8 plus a 0 plus a 0 plus a 1. And a C, that is 12. That's 1, 1, 0, 0. So that's a 1, that's an 8 plus a 4, then 0, 0. So just take the spaces out. And there's your answer. It's the binary version of that guy. Now, if you didn't know the trick, so that trick works for hexadecimal and it also works for octal. Okay? And we've shown it before. I think we've done it this semester. We definitely did it last semester. But in any case, if you didn't remember the trick or you weren't confident in the trick, you weren't screwed, right? You could still solve this problem. So probably the easiest thing to do would be to first convert this number to decimal and then go from decimal to binary. So if we wanted to convert 1B9C from hex to decimal, this is the 1's place, 16's place, 256 place, and what's this, 4096? So this is 1 times 4096 plus 11, so B is an 11, times 256 plus 9 times 16 plus 1, well, a C is, what, 12? 12 times 1. So that's going to be 4096 plus 11 times 256 is 2816. Plus 9 times 16, 144, plus 12, 70, 68. So that's the decimal version of that number. All right. Now you need to go the other direction, so the other kind of conversion. So we go from decimal to binary. So we keep dividing this guy by 2, recording the remainders each time. And I promise it will come out to this. is what it will come out to. I mean, we can do it if you want, but it'll come out to that. Okay? But obviously, this was the easier way of doing it, right? So on one hand, if you knew the shortcut, easy, super easy question. If you didn't, not a hard question, just a tedious question. In fact, actually, this part wasn't too bad, especially if you had a calculator. But the other part, just dividing by 2, or 18 times or something, wasn't horrible. After you got past the first couple, you then started getting into numbers that were reasonable, but whatever. Questions about that one? Okay, write a method named count spaces that takes a string as a parameter and returns the number of spaces contained within the string. Okay. So this guy will be, it's going to return the number of spaces. So it's going to return an int called count spaces. It's going to take a string as a parameter. We're going to loop through every element in that string, and we're counting something. So maybe we have an int count. Start that off at 0 because we've found 0 things at this point, right? Now I need to write my loop that takes me on a voyage through every single character in my string. So for int I is equal to 0, I is less than s dot length, I plus plus. All right. So that's going to take me through every bucket in my string. Because how many characters are in S? S dot length number of characters. Then you ask the question, well, how do I get an individual char from a string? I use the char@at method. And I want to ask a question. I want to say, is the current character I'm looking at equal to the character representation of a space? So if S dot char@I is equivalent to single quote space single quote. Okay, so I'm allowed to use the equivalence operator here because this guy is a primitive type. Several people did something like this. Okay, can't do that. Can't compare a string, especially in this case, a string literal, to this guy. But this guy is for object types. Okay, this guy is for comparing object types, this guy's for comparing primitive types. This guy is an object type. Won't work. It would allow you to compare memory addresses, but because we have a char here on the left-hand side, it's not allowing this anyways. If this was the only mistake you made, not the end of the world. It was because it was clear what you were trying to do, right? You're asking the right question, you're just asking it in slightly the wrong way. So if that's the only mistake you made, wasn't the end of the world. But that's the correct way of asking the question. Is the char that I'm currently looking at equal to the char representation of a space? That's with single quotes around it. If it is, count plus plus. After this for loop is done, return count. So this guy will take in a string, keep track of a variable for how many spaces we found, go through every element of that string, asking a question each time through. Am I looking at a space? If I am, add 1 to my count. Once I've gone through the entire string, return count, which should represent the number of spaces I found along the way. Make sense? All right, questions on that one? All right. Oh man, way too many people missed number 10. After like warning after warning after warning and saying it in class so many times. Okay. How can you tell the difference between a class method and an instance method at the time of their definition? So here's an example of us defining a method. We know that this guy is an instance method because he does not have the keyword static in front of it. Okay, so instance methods, when we define them, omit the keyword static. Class methods, when we define them, have the keyword static. So this is testing a couple things. First of all, you understand the difference between using a function and defining a function. This is me defining this count spaces function. I haven't actually used it yet, just defining it. So at the time of definition, when we're writing the function, writing the logic, we distinguish something as being a class method or an instance method by the keyword static. Static is there for class methods, is not there for instance methods. Make sense? Second part, how do you call a class method when you use it in your program. So to call a class method, we use the name of the class in which the method was defined. So static methods or class methods, we call using the name of the class in which the method was defined. In this case, I've written this class method inside of a class called midterm. So I would say midterm dot count spaces. Hello world or something like that. Because this guy was a class method because it was defined with a static keyword. We call it using the name of the class. These two guys match each other in which the method was defined. This method was defined down here inside of the midterm class. If I remove the static from this guy, now it's an instance method. Now this is no longer illegal. So the way I call an instance method is using an instance of the class in which the method was defined. So in this particular case, it's less clean, but I do have an instance of the class called this. So this dot count spaces. Oh, I can't use this in a static context because we're inside of main. So this would probably be a bad example, but I would say something like midterm MT is equal to new midterm. And then I would say MT dot count spaces. Okay, a little contrived, but same thing. So now we call instance methods using an instance of the class in which the method was defined. Okay, so difference between calling methods and defining methods, and understand where the static guy comes in and where using the class name or an instance of the class comes in. Make sense? Now, if you had to round down, how many times did we discuss that in class? Close to infinity. That's rounded down often, right? We bring that up often. So it's should not miss that one. So ones that were, generally speaking, people did a pretty good job in the Hello World program. You know, a couple of issues there. I think a couple people left it almost blank, which that shouldn't happen. So you got to question why you did that. But in general, people wrote the Hello World program all right. Difference between public and private, I don't think people had too much trouble with that. Number 3, the char primitive type. That one was missed more than I expected it to be missed. I know we've talked about that several different times. We expect even a class kind of looking at converting, doing math with chars. You know, taking a char, adding 1 to it. Like if you have char A or char C is equal to the letter A, and then you add 1 to it, you get a B. You know, seeing how the math actually takes you through the Unicode character set. So that one was missed more than it should have been. Number 4, write the necessary code to define an integer array capable of holding 25 integers. Should have been pretty easy. Was missed way more often than it should have been. Same thing with number 5, filling an array up with the number 5 a bunch of times. Number 6 was missed a lot. Again, shouldn't have been. Hopefully, the hope would be, now that you've seen the solution to the exam, any things you missed, the hope is you're kind of like, you know, like, oh, you know, that wasn't that big of a deal, right? You know, and that's okay, because that means you recognize that you either had a deficiency, you didn't understand something, or you had a brain fart or whatever it was. Or for some of you, maybe you had a brain fart day, or is that a thing where just everything went wrong? You're in the bad frame of mind, didn't sleep well the night before, whatever it is. Just, you know, at least you get a do-over with the final. But yeah, number 6 was missed too often, I would say, especially given that there really isn't much to it, but you did have to understand what we've been discussing about objects. Write a simple program that illustrates 2 variables with the same name that are distinct because they are in separate scopes. That one was missed somewhat often. I tried to be relatively lenient on it because I could certainly see how you can interpret the way I'm asking it maybe a couple of different ways. So if what you did kind of was an example of a reasonable interpretation of what I was asking, I kind of rolled with it. But I wanted you to show me you understood scopes. That's kind of the punchline there. Number 8, the conversion number. You know, I know that it's mathy stuff, but I almost put them on every one of my exams, and I warn you about it. So I'm just a big fan of conversion numbers, and I can't tell you how many people we graduate who can't convert numbers, and it's a requirement in computer science. You know, I mean, I get it if you're converting from base 3 to base 11 for no good reason. That might not be something you bump into, but the point is that converting between any two bases is the same. You do the same logic. But certainly in computer science, working with hexadecimal, octal, binary, I mean, those are go-to moves. We need to have those as computer scientists, and we need to be comfortable with those things. So even though I get it, it's a little tedious, we should all be capable of doing it, and you've all been introduced to it on several occasions. Number 9 should have been pretty easy. Write a method called count spaces. Again, was missed more often than it should have been. For the most part, though, I would say as a class, people answered it pretty competently. You know, you had some issues in there, you know, like some syntax problems that probably would have shaken out if you had thrown it into Eclipse or something, but in general, you kind of had the algorithm aspect of it done where I got to go through the string, I got to ask a question about each character I'm looking at. You might have messed the question up a little bit if you were comparing it to a string or something, but you generally knew you needed to go through, you needed to ask a question, and you only counted something sometimes. If you got that, you should have gotten most of the points on that one. Like I said, number 10 was missed way too often. There should have been 100% of the class got that one right. All right, any questions on the exam, general questions? Like I said, if you have a question about specific grading on your exam, just bring it up after class, and I'll tell you why I took off that many points, or if I was too harsh and you explain, you know, this is what I meant by that, and I believe you, then maybe I'll give you some points back. All right. So let's get rid of that, get rid of that. Now, after seeing now the solution to the exam, not too bad. Seemed fair. Maybe not at the time, but after the fact, now you kind of see the result. Shouldn't have seemed too terrible. We're in the middle of writing Mergesort, and I've introduced a error, I'm sure, right? Okay, perform the merge step. Oh, I just took out I haven't finished writing this. So let's jump back into our Mergesort here and finish that up, and then we'll start talking about Android. You know what? What are we doing on time here? 30. Okay. I might rush this a little bit because I want to make sure I introduce Android. So we'll just do it for completeness. So our Mergesort, we're calling Mergesort on our superstring. So our superstring already knows about the string it stores. It knows about S up here. We have a private variable. I think we called it S. Yeah. It knows about that guy. That's why Mergesort doesn't take a parameter in, because we know we're sorting ourselves. Okay. So then down here, so what does Mergesort do? It goes ahead and it converts our, it gets the character array version of our string. We store that inside of a variable called AR here. And then we ask the question, as long as I have something that's sortable, as long as there's at least 2 characters in it, let's go ahead and call our Mergesort helper. And notice I made Mergesort public, but I made Mergesort helper private. So that kind of goes back to the exam question about public versus private. We don't intend for people outside of this class to directly call this function. This is kind of a helper function for us to internally use. We want people who call this to call Mergesort. That's the one we want them to use. And then we do the extra steps to kind of give us the 3 inputs to this guy. Okay, so we call our Mergesort helper, we pass it the full array, and then we pass it the initial begin and end point for that array. Make sense? All right, so we're going to say it starts off at bucket 0, So that's the first legal bucket. The last legal bucket is the length of it minus 1. So we've set up a precedent for what begin and end are. Begin means the first legal bucket, end means the last legal bucket. So then down here in merge sort helper, we're getting an array. We're getting the portion of the array that this particular call to merge sort helper is interested in. So initially it's interested in the entire array, but then we're going to be cutting it in half. So another call, even though we're passing the whole array in, we're only going to be focusing on this position between begin and end, a portion of that array. Okay? So this is where we're asking the question, am I bigger than a one list? Because one lists are considered to be trivially sorted, right? If we're looking at something where begin and end are the same, that means we only have one element, and that element is sorted. We don't have to do anything special to sort one thing, okay? So only if I have to do special stuff do we go into this question. So if end and begin are different values, if end is bigger than begin, I have at least 2 elements, I need to do stuff. So I'm going to calculate the beginning of the first half and the ending of the first half. So beginning of the first half will be the same begin. The end of the first half will be end plus begin divided by 2. Okay? That gets me to the halfway point of the subsection, the begin to end that they've passed in for this. And it's important because if you try to just take end divided by 2, that works for the left half, but not for the right half when you're doing sorting. So end plus begin divided by 2 will always give you the correct halfway point. So that's the end of the left half. Notice that the end of the right half is whatever end used to be, just like the beginning of the left half is what begin used to be. And the beginning of the right half is whatever the end of the left half was plus 1. All right, so this is beginning and ending for left half. This is beginning and ending for right half. Make sense? Then we call merge sort helper on the left half, and we call merge sort helper on the right half. So we're calling this exact same function again on the left and the right half. All right, now, under what circumstances do we not do anything here? When we get to a one list. So when these guys are a one list, this will finish, this will finish. So the very first time we come through here, I'll be dealing with 2 one lists. All right, so that's when we do our merge sort, our merge step. So we wrote down here some of the things we know here. We know that the array from B1 to E1 is sorted. So in the first time through, it'll be the one list, so it's trivially sorted. B2 to E2 is sorted, so now we must merge them together. So what do? Well, we create an array that's big enough to hold those guys, okay? Because we have 2 half lists, right? So now what I need an array big enough to hold all of these elements. But I'm going to put them in the right order. All right? So I'm going to take end minus begin plus 1. That's going to give me my array of the correct size. I'm just kind of giving myself a side container here for me to do my merge step. And then what's my merge step? My merge step says I'm going to start at the beginning of each of my 2 lists. I'm going to say, who's the winner between these guys? Is this guy smaller or is this guy smaller? Whoever the winner is, I'm going to pick that winner, bring it into my next bucket in my answer array, and then increment that winner position. Make sense? So we're going to have a couple of pointers here. So we'll call this guy int pos1, and we'll start this guy off at B1, the beginning of the left list. We'll have int pos2, and we'll start this off at B2, the beginning of the right list. Now, we know we're going to have to place temp.length number of things. That's the number of times we're going to have to go through this, because that's the number of elements there are. So for int I is equal to 0, I is less than temp.length, I plus plus. We're placing temp.length number of elements, all right? And each time we're placing it at bucket I. So the first time we're putting our winner at bucket 0, then our winner at bucket 1, then our winner at bucket 2, so on and so forth. Okay? So now, we're going to ask the question. First of all, we want to ask the question, if they are both legal positions. Okay, so if pos 1 is currently pointing at a legal place in the left half, and pos 2 is currently looking at a legal place in the right half, what do we do? So if pos 1 is less than begin to, if I'm still pointing to something on the left half of the list, and pos 2 is less than or equal to E2. So as long as pos 1 is sitting somewhere, and if it makes you feel better, you can say less than or equal to N1 here, if you want them to match up nicer. They're saying the same thing, right? So, this is pos 1 somewhere on the left-hand list? Is pos 2 somewhere on the right-hand list? If it is, then I know I'm dealing with legal positions and I need to pick a winner. All right? So if I'm inside here, then I can ask the question, if AR at bucket pos 1 is less than AR at bucket pos 2. If that's a true statement, what am I going to do? I'm going to say temp at bucket I gets my current winner, which is AR at bucket pos 1. And since I declared pos 1 to be the winner, I'll increment pos 1. So I ask the question, who is the smaller character, AR at pos 1 or AR at pos 2? If pos 1 wins, I'll go ahead and store that guy in bucket I of my solution, my temp, and then increment pos 1 because we've already placed that value. Otherwise, pos 2 must be the winner. So we'll say temp at bucket I is equal to AR at position pos 2. So we'll place that guy as the winner and then increment pos 2 because we've already placed him. All right, so that's what we do if pos 1 and pos 2 are both legal positions. Now, if we didn't make it into that first if statement, that means either pos 1 or pos 2 has gone off the end of their respective lists. And therefore, by default, we declare the other guy the winner. All right, so else if pos 1 is less than or equal to E1. So if pos 1 is still the legal position, then we'll say temp at bucket I is equal to AR at bucket pos 1. And then we'll say pos 1 plus plus. So if they weren't both legal, then if pos 1 was the legal guy, declare him as the winner, increment pos 1. Otherwise, pos 2 must have been the legal position. So we'll say temp at bucket I is equal to AR at position pos 2 plus plus. All right, and we're going to do this merge step the exact correct number of times, temp.length number of times. So we should naturally hit the end. There will never be a situation when we're inside this loop where both pos 1 and pos 2 are at illegal positions. Okay? So now when this is done, temp holds our values in order. We need to copy them back into AR between begin and end. All right, so I have this separate little bucket sitting here with all my values in the right order. Now I need to go and I need to insert each of those into the correct place in AR, the portion of the array that we were currently sorting. So I'll say for int I is equal to 0. So this is going to take us, so we'll use I to take us through temp. And then we'll say int j, actually it's just a say J is equal to begin. Keep going as long as I is less than temp dot length. I plus plus. All right, so we haven't done this very often where we've had two different counters inside of here. I would say J plus plus here as well. So if you're not comfortable with having I being our controller for temp, J being our controller for where we need to go inside of AR, then you could always define the second variable and the second counter outside of the for loop as just separate variables. But all this does is creates a for loop that has two counters, and each time we change each of those counters. And what are we doing? We are copying into AR at bucket J the value that lives in temp at bucket I. AR at bucket J is equal to temp at bucket I. So that'll overwrite our actual array in memory in the correct positions with our now sorted values. All right, finally I'll close my curly brace for this if statement, because we ever call Mergesort helper on something that is already a one list, we do nothing. We literally do nothing. There's nothing to sort, there's nothing to merge, it's one value. So we're only doing all of this stuff in the event that we have at least two values. And each time through, after we've done our little temporary thing, this is the final magic here at the end where we actually copy our answer that we stored inside of temp back over the original values in AR. That makes sense? So when all this is said and done, when we exit out of our Mergesort helper here, AR has its values sorted in place because we had passed in the memory address. So this guy gets passed by address. So therefore, all those times where we copied back stuff back in, it was copying it into the actual memory location of AR. So now we need to turn AR back into a string and store it in S. All right, we saw there was a constructor for the string class that allows us to build a string out of a char array. If we don't like that, we can also start off with the empty string and just concatenate it up. But we'll go ahead and say this dot S is equal to a new string built out of AR. So this constructor from the string class knows how to take a char array. Let me show that to you here. So go to java.lang. We'll go to the string class. We'll see the string class has a bunch of constructors down here. Here's the constructor summary. So here are the various people we can hire to build strings for us if we want to compare, connect this back to real life. All right, one of these guys allows us to pass in a char array and says, go ahead and build me a string given this char array. If you didn't know about that, you didn't have the documentation sitting in front of you or didn't know about that ahead of time, you could have always done, instead of that, you could have always done this dot S is equal to the empty string, for int I is equal to 0, I is less than AR dot length, I plus plus, this dot S is equal to this dot S concatenated with AR at bucket I. Just build the string up yourself. And for all we know, that's how the constructor works under the hood anyways. So this guy right here and this guy right here, effectively do the same thing. I'm not promising you they do it in the same way, but the ultimate end thing is identical. All right, so I'll comment this out for right now. We'll just do the constructor version of this. So that means after we call Mergesort and we do all these calls, in the end, we're replacing S with the now sorted version of AR. So our string should be sorted at that point. So here's our string hello. We print it out. Instead of calling insertion sort, we're going to call Mergesort. And that's the public function we have. Mergesort helper, notice, is not showing up there because it was private. And then we'll go ahead and print out S afterwards. And there's S sorted. Okay, so now, since we're all in mourning from the exam, let me give you a little bit of a reality check here for this guy. Most of you should have found this difficult to follow. Okay, so I'm going to put the code up on there, but recursion is difficult for beginning programmers. In fact, you probably won't feel comfortable with recursion until you get into the 470 class. So I'm really giving you a pep talk because I'm nearly positive that almost every single one of you had problems following this. Probably a couple of you that maybe have had a lot of programming before. If that's the case, you're exactly where you're supposed to be. All right? Because this is difficult to follow, but it is kind of an important algorithm. But whatever. All right, so it'll come back to you again. You'll see Mergesort in the future. I probably won't test you over like write Mergesort on an exam or something, but we should appreciate this idea of recursion and that kind of stuff. All right, but I just wanted to throw that out there because, it would be pretty easy if you just did poorly on an exam for you to sit there and say, oh, I'm completely lost in here. You probably should have been for this example. Maybe not completely lost, but lost enough. Okay, so I'll go ahead and throw that up on Slack. And then let's start with Android Studio. You see, I feel like they really need to have Slack when it first opens start on a general or something. Because this is very important. We don't land on this guy right here. So that would be terrible if that's what it opened up to and it was all recorded. And yeah, it's a thing. All right, so let's code snippet. Let's Mergesort. But there's all other reasons for it too. Like for instance, if I switch to it, I wouldn't want like a private message between me and a student, showing up on there if they were asking me about grades or something. So other more legitimate problems with the situation. Okay, so having said that, I'm going to actually paste a couple of links in there as we go through this. So we're going to be switching tools now that we're using in class. And actually, the tool we're going to be using is called Android Studio. And when you did Android programming historically, you would use Eclipse. And then Eclipse supports plugins. So you would download the Google's plugin for Eclipse that allowed you to do Android development. Well, eventually, as Android development kept evolving, what they ended up doing, Eclipse is an open source project. So they at least started with that as a base, because when you use Android Studio, you feel like it's Eclipse. A couple of things have changed, but it's 90% Eclipse. So there's not a huge learning curve there. And I have seen it from both perspectives. So I've seen Eclipse with the plugin and then now Android Studio, and you can tell they're the same thing. So they took Eclipse and they basically made an integrated product. So then you didn't necessarily need to do that whole, connecting the plugins, installing the plugin stuff. So it made life even easier for us. So where you'll go, we'll go to developer.android.com, and I'll give you the direct link to it. Okay, so this is going to take you to Google's website for all their developer stuff. All right, the thing we're interested in is Android. All right, so it takes us to Android, and here's the newest, latest, greatest version of Android here. And oh, hold on, I'm sorry. We got to go back here. I'm going to go to develop, which takes you in. Here's the Android section for that guy. And then down here, we have a thing called Android Studio, and I'll give you the direct link to this.
You have a link on your Wi-Fi already.
Okay, I'll put it in Slack too, just for convenience. All right, so this will take you to Android Studio. Paste that in there. All right, so this is going to be your new Eclipse. All right, so you can close Eclipse on your computer. You'll download Android Studio. It's 3.0 on the Mac and whatever. It's probably the same version number or very similar on the Windows side. I actually already have it on this machine, but actually I have, it's 3 point something, but it hasn't had the latest update. So when I open it here, it'll scream and say there's an update. I'm going to ignore it for right now. But when you install it, you'll get something that looks like this that'll open. Okay, yeah, platform and plugin updates, blah, blah, blah. When you first open it, though, when you first open Android Studio, the very first time, because the download isn't that large when you first download it from Android. You probably want to do this overnight at your house. It's probably a 1.5 gigabytes or something like that total download, or in that ballpark. If you have a good internet connection, it might only take 5 or 6 minutes, but whatever. Just do it overnight before you go to bed, so it's definitely done by the morning. But it'll kind of guide you through what you need to grab. But there's kind of 3 important pieces. That are usually checked by default, but I'm going to highlight them here. All right, so Android Studio. You already have the link for it. So it's going to have you install latest SDK, software development kit for Android. So what it'll do is it's gonna pick it for you. It'll tell you install this. You don't have to. It gives you the option to check 30 of them if you want to have every SDK that's ever existed for Android Studio. Just go with the default one that they give you and be done with it. All right, you don't have to check all of them. So Android is a platform where there's people. How many of you are Android users in the audience? All right, so 4.25. All right, so do you know what versions of Android you have on your device? Android 6. There is an 8. Do you have a Pixel? Okay, so yours is not 8. So yours is a newer phone. So yours is probably 7 something.
Probably
6. Jacob, do you know what yours has? Okay. Yeah, so I mean, this is the latest. This is Galaxy Note 8, so the phone that just came out from Samsung. This is not running Oreo. This is still running 7.3. The only phones that are running Oreo right now are the Google Pixels, the phones that are actually made for Google by another company.
Show hers off to you.
Huh? Yeah, she did. Yeah, but the punchline is that if you're developing for this, I mean, most of you in here would say you have viable phones, right? Your phone isn't like a piece of garbage. So if I'm writing software for Android, I would probably target Android 6 or Android 5, something that is new enough to give you most of the features that you expect, but that can hit an audience. Because right now, if I develop for Oreo for Android 8.0, I'm literally targeting 2 devices: the Pixel 2 and the Pixel 2 XL. They're the only 2 devices in existence that support Android Oreo. I think actually the original Pixels might have had the update now, but regardless, very small subset of devices will support it. So it'll pick the SDK, and that it's backwards compatible. Okay, so you'll get the latest greatest SDK, but built into that will be the changes. So when we actually go to deploy, and we'll look at this next class because we're running short on time, but we go to like build our project, you choose the SDK you're targeting, and it makes the choice for you. You know, the default is like SDK number, even though we're talking about Android like 6.0 and 7.0 and some of that. There's like intermittent ones like 7.3. So that's like SDK number. I think the default one is like 17. And SDK 17 covers 100% of the devices that are out there. So as long as you have that or newer, you can run the app. If you want to deal with some newer features that came out in a later SDK, you can bump it up a little bit, and each time you change it on the project creation page, it'll tell you what percentage of the devices you're targeting now. You know, so if you're comfortable in the mid 80s or something like that, you can get most of the new features. But you know, it depends on how big your audience you're going to be for, you know, the thing you're targeting. For us, we don't care. You know, we're learning the tool, and it's not going to be a major issue for us in here, but just something to keep in mind when you go out there. So latest SDK, and then this is the important thing. This thing called Haxum. And it should install by default. There'll be a checkbox somewhere, and I believe the checkbox is checked by default. Do you want to install Haxum? Do any of you have AMD processors in your laptops? Okay, you might run into problems with Haxum. So I don't know if they fixed that or not, so just be prepared. You'll be able to do the thing anyways, but you might not be able to use Haxum. So you have to see if it fails or not. And this next part's going to tick you off, actually, because one of the problems early on with Android Studio is, so we have an emulator, you know, because now you have a phone. So you'll luck out because you can test on your phone directly. So you'll actually be okay. But most people don't have an Android phone, or at least don't maybe want to develop on it directly. You don't want to plug your phone into your laptop every single time you want to develop. So there's an emulator that launches. It's basically a software application that looks like an Android phone. All right. Well, that software application without Haxum takes somewhere between 20 minutes and a decade to launch on your machine. So I encourage people to, once it's launched, don't close it. Just leave it open. Haxum, it loads almost in 8 seconds or something. It's quick. So there was a major issue with the emulator. So you could try it and see if they have it fixed. Otherwise, I would strongly encourage you to probably just test on your real device. Otherwise, you won't be happy. But if everybody else is running Intel-based processors, and it's possible Haxum has been fixed for it, I'm just kind of giving you warnings from past experience. Haxum just works. There's not an issue. All right, so I'll put up the new Bible homework that'll be due on Thursday. I'll put that up today. But for Thursday, go ahead and get Android Studio installed on whatever your computer you use for your homework, and get everything updated, and go through the little Hello World tutorial they have on there. You literally just open it up and hit play. Just make sure you have a working emulator is what I'm getting at. There's nothing you even have to do. It's a 45-second thing.
And the emulator is already on.
It's built into Android Studio. Yeah, all you have to do is download Android Studio, install it, and then do that. When you actually open it, it takes you through like 2 or 3 windows. You have to hit next a couple times, make sure Haxum is checked, and then let it do its download thing. It downloads for an hour or something like that. All right, I'll see everybody on Thursday.